Okay, let's take a look at number 2 in section 4.2. We're going to use linear approximations to estimate the change in f, which is going to be f of 3.4 minus f of 3. That's what they give us for the function f of x equals 3 divided by 1 plus x squared. So remember, this is going to be the f of a plus delta x. This is f of a. So clearly a is 3, and therefore delta x has to be 0.4, since 3 plus 0.4 equals 3.4. So we do need to estimate that then with the linear tangent line. The linear approximation would be f prime of a times the delta x. So I need f prime of a. So let's get the derivative over here. You can use the quotient rule on this, and that's fine. You can also rewrite it this way, right? 1 plus x squared to the negative 1, and just use the chain rule. Bring the outer function is u to the negative 1. So bring the negative 1 down times the 3 is negative 3. U, which is 1 plus x squared to the negative 2, times the derivative of what's inside. Derivative of 1 plus x squared is 2x. So negative 3 times 2x is 6x. 1 plus x squared to the negative 2 goes down here in the denominator. So there's our derivative. So what is the derivative at a, which is 3? If I plug in 3 up top, I'll get negative 18. Down here, I'll get 1 plus 3 squared. 1 plus 9 is 10. 10 squared is 100. So negative 1800ths is the value of f prime of a. So f prime of a is that, delta x is 0.4, multiply them, and this is our estimate. This is our estimate. This is exact. In fact, they wanted it, I think, to 3 decimal places, but it's exactly that, to 3 decimal places. Okay, so that's the estimate. What is the actual change? So what are we estimating? Well, just what is this quantity here for this function? Well, plug in 3.4 into this function. I get this. Plug in 3 into this function. And notice what I get. 1 plus 3 squared is 1 plus 9 is 10. I get 3/10, which is 0.3. So just entering this in the calculator, and it looks like this for me. 3 divided by the quantity, 1 plus 3.4 squared minus 0.3 gives me that. They did want us to round this to 6 decimal places, so just be careful. In this case, again, the 6 is in the, if this is a 4, or less, we keep it 6. But if this was 5 or more, you'd have to round that up to a 7. So just be careful about the rounding issue there. Excuse me. So that is the actual change. And you can see the difference between our estimate and the actual change. What is the error in our approximation? Well, we're just going to take the difference between these two quantities. And we do want the absolute value of that difference. So I'm just going to take this quantity, subtract the other one, take the absolute value, and I get this quantity here. They also wanted that to 6 decimal places. So there it is. That is the error in the linear approximation, just the difference between these two quantities, the actual change and our estimate. What's the percentage error? Well, the percentage error is the error as with respect to the actual change. What percentage of the actual change is this error? So we're going to take the error, divide it by the actual change. And again, we'll take the absolute value of that. This comes out to be 0.1775 about, rounded off. And if you multiply by 100%, of course, that decimal place moves twice, and you get 17.75. I think they wanted it to 2 decimal places. Again, I'm not sure if they want the percentage sign in there. I don't think so, actually. But there is the result. Okay, hope this helps on number 2.